Let's talk about graduation of metallic and non-metallic property in the periodic table. First, let's talk about them in periods. Each period starts with strong metal in group 1A. Then the metallic property decreases gradually by increasing the atomic number. So metallic property decreases in periods by increasing the atomic number, till we reach metalloids. Then the non-metallic property appears and increases by increasing the atomic number. So non-metallic property increases in periods as we go from left to right by increasing the atomic number, till we reach the strongest non-metals in group 7A or 17, just before group 0, which is noble gases. But in groups, we will talk about metallic groups, such as group 1A and 2A. In groups, the metallic property increases gradually as we go from the top to the bottom. And this is an important give reason question. Metallic property increases in groups by increasing the atomic number. This is because the atomic size increases. As we go from up to down in groups, the atomic size increases, and hence the metallic property also increases. For example, in group 1A, cesium is considered the most metallic element in group 1A, while lithium is considered the least metallic element in group 1A. In groups, but in this time we will talk about non-metallic groups such as group 7A. The non-metallic property decreases gradually as we go from the top to bottom. Give reason 4. This is because the electronegativity decreases. In group 7A or 17, fluorine is considered the strongest nonmetal in group 7A, while iodine is considered the least non-metallic element in group 7A. Now let's talk about the chemical properties of metals. The reaction of metal with, number 1, dilute acids. The reaction with oxygen, and finally we will talk about the reaction with water. So to study the chemical properties of metals, we will talk about the reactions with dilute acids, oxygen, and finally with water. Reaction with dilute acids. Some active metals, such as magnesium and zinc, react with dilute acids, such as hydrochloric acid, HCl, giving salt of acid, and hydrogen gas is evolved. Mg plus 2HCl diluted salt of acid, which is magnesium chloride, is formed and hydrogen gas is evolved, as we can see from this video. We can do it in another way. We can prepare a piece of zinc and we will try to collect the evolved gas, which is hydrogen. To prove that this gas is hydrogen, we will approach a flame to it. As you can see, it will burn with a pop sound. This proves that this gas is hydrogen. But inactive metals such as copper don't react with dilute acids and no gas is evolved. As you can see, this test tube contains a piece of copper and you can see there is no reaction. So Cu plus 2HCl diluted, no reaction. Metals react with oxygen, forming metal oxides. For example, the reaction of magnesium with oxygen. As you can see in this video, a white powder is formed, which is magnesium oxide. The chemical equation for this reaction is 2Mg plus O2. Heating, it will give 2MgO. Some metal or basic oxides, such as magnesium oxide, dissolve in water, giving alkalis or metal hydroxide, which turn litmus solution into blue. For example, MgO, which is magnesium oxide, plus water, H2O, it will give MgOH by 2, which is magnesium hydroxide. This is the reason that metal oxides are called basic oxides, because they dissolve in water, forming alkaline solution. Some metal oxides, such as iron 2 oxides, don't dissolve in water. So we have to say some metal oxides dissolve in water, because we have some examples for metal oxides which don't dissolve in water, such as iron 2 oxide. The final reaction is the reaction of metals with water. The reaction of metals with water depends on the position of metal in the chemical activity series. What's meant by chemical activity series? It is a series in which metals are arranged in a descending order according to their chemical activity. This is what is called chemical activity series. As you can see, it is divided into 4 categories. We have to memorize them. The first category contains potassium and sodium. They react instantly with water, and hydrogen gas evolves, which burns with a pop sound. The second category contains calcium and magnesium. They react very slowly with cold water. The second category contains zinc and iron, and they react only with hot water vapor at high temperatures only. The final category contains copper and silver, and they don't react with water at all. As you can see, what's meant by chemical activity series? It is the series in which metals are arranged in a descending order according to their chemical activity, from more active to less active, and finally to inactive. Let's see the reaction of elements with water. This is the reaction of potassium with water. It happened instantly. This is the reaction of sodium. Also, it happened instantly. If we try to collect the evolved gas and we approach it from the flame of the candle, you will notice that it burns with a pop sound. The second category is the reaction of calcium with water. As you can see, this reaction is slower than that of sodium and potassium. The reaction of magnesium is much more slower than that of calcium. Here you can see the reaction between magnesium and zinc sulfate, and also between zinc and magnesium sulfate. This only to show the difference in their activities. This is to show the activity of copper and silver. As you can see, there is no reaction at all. Now let's talk about chemical properties of nonmetals. The reaction of nonmetals will be with only dilute acids and oxygen. Reaction of nonmetals with dilute acids. Nonmetals such as carbon and sulfur don't react with dilute acids such as hydrochloric acid. Reaction of nonmetals with oxygen. Nonmetals such as carbon and sulfur react with oxygen, giving nonmetal oxides, which are known as acidic oxides. For example, C plus O2 by heating, it will give carbon dioxide. If we heat a piece of coal in oxygen, carbon dioxide will be formed. Also, if we do the same with sulfur, by heating sulfur strongly and putting in a container that contains oxygen, sulfur dioxide is formed, which is a non-metal oxide or an acidic oxide. Non-metal oxides dissolve in water forming acids, which turn litmus solution into red. If we bring dry ice, which represent carbon dioxide, and dissolve it in water, carbonic acid is formed. And as you can see, by using litmus solution, its color will change into yellow or red, because carbonic acid is an acid. So when non-metal oxides dissolve in water, they will form acid. By heating sulfur strongly and by putting a litmus paper at the mouth of the test tube, you will see that the blue litmus paper will change into red. This proves that sulfur dioxide is an acidic oxide. Now let's compare between basic oxides and acidic oxides. Basic oxides, they are metal oxides. Acidic oxides, they are non-metal oxides. They are formed by the reaction of metal with oxygen, while acidic oxides, they are formed by the reaction of non-metal with oxygen. Basic oxides, some of them dissolve in water giving alkalis, but all acidic oxides dissolve in water giving acids. The solutions of acidic oxides turn litmus solution into blue, while the solutions of acidic oxides turn litmus solutions into red. Examples for basic oxides such as sodium oxide and magnesium oxide. For acidic oxides, we have carbon dioxide and sulfur dioxide. Finally, let's talk about something called amphoteric oxides. What's meant by amphoteric oxides? Let's do this experiment. First, we have a test tube that contains sodium hydroxide, and this one contains hydrochloric acid. This is an alkaline solution, and this one is an acidic solution. As you can see, aluminum oxide reacted with both of them, and in each case of them, it will give salt and water. Give reason for some metal oxides such as aluminum oxides, Al2O3, are known as amphoteric oxides. This is because they react with acids as a base and also with a base as an acid, giving in the two cases salt and water. Thanks for watching. This is the end of lesson 2.